Now a very important thing, that is, in each and every group, that is 1 to 18, a very important thing has to be understood and has to be memorized as well. And what is that? That has to be kept in mind for solving the questions, for solving the problems from this chapter. And that is, the groups are not numbered without any reason. Okay, they are not numbered by choice, they are not numbered by wish. No, there is a scientific mathematical reason behind this, and that is the valence electrons, and that is valency, and not that is valency but and valency. Okay, so the first group elements, they have the same valence electrons. The second group elements, they have the same valence electrons. The third group elements, they have the same valence electrons, and so on. Okay, and valency. So what is the meaning of valence electrons? Valence electrons means number of valence electrons. Valence, I'm writing electrons as in short. Okay, electrons, E minus, electrons, S for the plural. E minus stands for electron and S for the plural. You can use this abbreviation. Okay, this is acceptable in chemistry. So valence electrons, number of electrons in the outer most shell of an atom. Okay, what does it mean? If you have carbon, suppose carbon, what is the atomic number of carbon? That is 6. If you write the atomic electronic configuration, that is 2 and 4. If you draw the structure of carbon, the first shell will have 2 electrons from this. Okay, 2 electrons, and the second, that is the last shell, will have 4 electrons. 1 2 3 4. Okay, 1 2 3 4. So the last shell is having 4 electrons, and this is the valence electron. These are the valence electrons. So now you understood what valence electrons means. Valence electrons is the number of electrons present in the outermost shell of an atom. Okay, so it is an example of carbon, and you understood that carbon has 4 electrons in its outermost shell. So that is the valence number, that is the valence electrons. Okay, so group numbers are equal to the number of valence electrons of each and every element in that group. Okay, so the first group elements have 1 valence electrons. The second group elements have 2 valence electrons. All the elements will have 1 electron in the outermost shell. The second group elements will have 2 electrons in the outermost shell, and so on. And so on. Now, there is an important thing, a very important point which I would like to make over here is that, what is valency then? What is valency? Valency is the combining capacity of an atom. It is the combining capacity of an atom, which in simple word means number of electrons loosed or gained, number of electrons loosed or gained to become stable. Now try to understand this one. Now, what is electronic stability? What is electronic stability, and why atoms they lose electrons? Okay, electronic stability, it is of 2 types: octet, duplet. What is octet? 8 electrons in the outer shell, outermost shell. Duplet means 2 electrons in the outermost shell. Okay, So what happens? All the elements, all the atoms of the elements, they are unstable except the neutral, except the 18th group elements. They are the inert gases. Why they are inert? Because they are stable in nature. So what happens? The atoms, because they are unstable, they try to become stable. Okay, because of their instability, they try to acquire the electronic configuration of the noble gases, of the inert gases. They try to replicate them, they try to yani they try to copy them. Okay, if they will copy them, they will become stable. And what do I mean by electronic stability or electronic they try to replicate the electronic configuration of the noble gases? Either they have the octet electronic configuration or the duplet electronic configuration. If you closely look at the inert gases, it starts with helium, and helium has 2 electrons. Okay, helium, the atomic number of helium is 2, and if you draw the structure of helium, it will have only 2 electrons in the first shell. So this is what duplet means. If an atom will have only 2 electrons, either by losing or gaining electron, if an atom will achieve only 2 electrons in its shell, it will behave, it will copy helium, and that is what it will have, the duplet electronic configuration, and that is why it will be termed as stable, or it will become stable. Similarly, majority of the atoms of the elements, what they do, they try to have 8 electrons in the outermost shell. That is, they try to duplicate, they try to replicate, they try to copy, they try to imitate the other noble gases like neon, xenon, radon. Okay, all of these inert gases, they have 8 electrons in the outermost shell. So the majority of the atoms of the elements, they achieve 8 electrons either by losing or gaining in the outermost shell, and thereby they become electronically stable. Okay, so they achieve octet electronic configuration. I hope you understood what does electronic stability means. Okay, now coming back to the definition of valency. So it's combining capacity of an atom, that is number of electrons lost or gained to become stable. Okay, so suppose in this example, carbon, it has 4 electrons. Now how to decide whether it will lose 4 electrons to achieve the duplet electronic configuration, or it will gain electrons, 4 electrons, to become octet electronic configuration? This is the confusion. Okay, now I have explained you that either an atom loses or gains, but who will say, who will identify, who will make you understand, how will you determine that whether an atom will gain or lose? Okay, just follow a simple rule. And what is that? A very simple rule. What is that? Atoms having 1, 2, 3 electrons in their outer most shell, lose electrons. So if you will find that the atoms which have either 1 or 2 or 3 electrons in the outermost shell, they will lose electrons. So you have to lose electrons there to make them stable. For example, let us take an example of sodium. The atomic number is 11. Okay, so that is 2, 8, 1. So you can see it has only 1 electron in the outermost shell. Similarly, you take the example of calcium. The electronic configuration is, the atomic number is 20. So that is 2, 8, 8 and 2. So you see the last shell has 2 electrons only. Similarly, if you take an example of aluminium, the atomic number is 13, 2, 8, 3. It has 3 electrons in the outermost shell. So in all of these examples and similar sort of elements which have which belong to the first group, belong to the second group, they belong to the 13th group. Okay, not the third group. This aluminium belongs to the 13th group. I will be explaining you. Wait for a second. Now let us just try to understand that if the last shell has only 1 electron, 2 electron or 3 electron, they will lose electrons. They will lose electron, not gain. So if you remove 1 electron from here, it will achieve the octet structure. If you remove 1 electron, 2 electrons from here, it will achieve octet structure. If you remove 3 electrons from here, it will achieve octet structure. In all of these cases, removal of electron will come to play. Now where the gain of electrons occur? Where do the gain of electrons occur? Atoms having 4, 5, 6, 7 electrons, that is more than 3, gain electrons. So for example, you take example of oxygen, that is, take an example of nitrogen, 7, the atomic number is 7. You write the electronic configuration 2 and a 5, okay, 2 and a 5. So you can see thus the second shell needs 3 electrons to become octet. Why? Because it has more than 3 electrons in the outermost shell. Any atom having more than 3 electrons in the outermost shell will gain electrons. So 5 will gain 3 electrons and it will become octet. Similarly, if you write the electronic configuration of oxygen, it has 2, 6. So it will gain 2 electrons to become octet. Similarly, if you write the electronic configuration of chlorine, that is 2, 8 and a 7, it will again gain 1 electron to become octet. So the main concern is to achieve the noble gas electronic configuration, the closest noble gas electronic configuration, that is either a duplet or an octet. Okay. So in the case of lithium, it has 3 electrons. 3 atomic number is 3. If you write the electronic configuration 2, 1, it has 1 electron. It will be removed. So it will acquire a duplet electronic configuration and it will become stable. Now, I think that most of you are thinking that how am I writing this electronic configuration? My dear students, you might have studied this, how to write the electronic configuration in class 7 and class 8. But I don't think so that all of you have understood properly. So I think that I have to make you understand how to write the electronic configuration of atoms, because this is of utmost importance in the chapter, without which you will be unable to answer many of the questions. But for that, you have to do a job. Unless and until you don't do that, I will not explain you. And what is that? Very easy to do. You can see the periodic table in front of you. Please memorize the periodic table in this manner. Okay? Hydrogen, helium in this sequence. The numbers are given 1, 2, 3, 4 in the same sequence till 20. Okay? Maintain the sequence. Don't memorize them in haphazard way. Okay? If you memorize the elements in the proper sequence till 20, at least till 20, I will explain you how to write the electronic configuration in the next class. That's your assignment, that's your homework. All of you have to do that, without which this chapter is very difficult. Okay. Okay.